Example number 3. Sketch the graph of f of x equal cosine of x over 2 plus sine x. So step number 1, we find the domain. The domain for this function is all real number because the bottom can never be 0. We know that sine of x is between -1 and 1. So the smallest value of sine of x is -1. Add 2 will give positive. So basically 2 plus sine of x is always positive. So it can never be 0 for the denominator. Step number 2, we want to find the intercept. To find the y-intercept, we let x equal to 0. So x equal to 0, we get f of 0 equal cosine of 0, 2 plus sine of 0. Cosine of 0 is 1, and sine of 0 is 0, so 1/2. To find the x-intercept, we let y equal to 0. So for the function equal to 0, cosine of x have to be 0. So cosine of x is 0. We have pi over 2 and 3 pi over 2. We're going to pick the smallest number, which is pi over 2 plus k pi. For k is an integer. Step number 3, we will check for symmetry. But you notice that this function, if you add 2 pi for the input x, then the cosine is a periodic function, so it will be the same, and then this will be the same. So then this is mean that f of x plus 2 pi is the same as f of x. So f is 2 pi periodic. Step number 4, symmetry. So to find the step number 4 is the asymptote. To find the vertical asymptote, we need to looking for the value for the bottom equal to 0, but we noticed before the bottom cannot never be 0, so no vertical asymptote. What about horizontal asymptote? If the x approach to infinity, the y value does not approach to any specific number, so no horizontal asymptote. So what we can say is no asymptote. Step number 5, we will find the derivative for the function f of x. We're going to use the chain rule. So that would be 2 plus sine of x times cosine prime is negative sine of x minus cosine of x, and then 2 plus sine of x prime is cosine of x divided by 2 plus sine of x squared, and we simplify this. We distribute, open the parentheses, so we will get, it will become sine square and cosine square right here. So you open the parentheses and you will see that. So it's equal to 2 sine of x plus 1 with the minus in the front. Okay. So f prime of x equal to 0. The bottom cannot be 0. So to find the critical point, we just need to set the top equal to 0 and find the value of x. So sine of x is negative 1/2. So let's draw the unit circle. So we have this point right here, which is 7 pi over 6, and 11 pi over 6 will give sine is 1/2. So x equal 7 pi over 6 and 11 pi over 6. we noticed that. Let's go back to step number 3. Since f is the periodic function, so we just need to look at the interval from 0 to 2 pi, and then we will just copy, okay? So I just work in the first revolution. Now step number 6, we will find the local minimum and local maximum. So we need to know where the function f in f prime positive or negative. So f will be increasing or decreasing. So we're gonna type from 0 to 2 pi only. So let's forget about the negative infinity and positive infinity. And then we will plug in 7 pi over 6 and 11 pi over 6. Okay, so from 0 to 7 pi over 6, for the side, it is we will plug in, for example, we can check the point, like we will check like pi over 2, yeah. And then 7 pi over 6 to 11 pi over 6, you can check the point 2 pi over 2, and 11 pi over 6 to 2 pi, you can check this little piece. Okay, so you know this is like 330, right? So you can check like 350. Okay, so plug in the f prime, so in the degree. Okay, so just put them in the calculator, and what do you will get is minus right here, plus right here, and minus right here. So just check that with the calculator. Okay, so then will be increase, decrease, increase. So now we answer function f of x is increasing on 7 pi over 6 and 11 pi over 6, and f of x is decreasing on 0 to 7 pi over 6 union 11 pi over 6 comma 2 pi. So the next step, we can answer the local max and the local min in step number 6. So step number 6, we can see that right here is going to be local max, and right here will be local min. Okay, so we will plug in. So local max will be f of 11 pi over 6, and just plug into the function, you will get 1 over square root of 3, and local min, you will plug into the function, you will get negative 1 over square root of 3. Now the next one is we will find the second derivative, so f the param. So let's write out f prime, copy down f prime first. So it's going to be negative 2 side of x plus 1 divided by 2 plus side of x square. Okay, now take the second derivative. We use the chain rule. We're going to leave the minus outside. In the bottom will be 2 plus side of x to the 4th power. And then we will have 2 plus side of x square multiply the derivative of the top is 2 cosine of x. And then minus 2 side of x plus 1 for the top, and the bottom you take the derivative, so that would be 2, and then 2 times sine of x to the power 1, and then cosine of x. We notice that we have 2 sine of x, 2 sine of x, and then 2 sine of x. So what I'm going to do is I will factor the 2 plus sine of x out. So what I have inside the parenthesis is 2 plus sine of x multiply 2 cosine of x minus 2 cosine of x times 2 sine of x plus 1 divided by 2 plus sine of x to the fourth. Okay, we can cancel now this one and this one. So then we will get, we can open the bracket also, so we just have minus, and then in the bottom we will have 2 sine of x to the third power. Now open the parenthesis, we distribute. For this, we will get 4 cosine of x plus 2 sine of x cosine of x minus 4 sine of x cosine of x. I multiply this, right? Distribute. And then minus 2 cosine of x. Now we have a lot to cancel. And we will get a factor also, negative cosine of x 1 minus sine of x. So you need to work on one more step, okay, to get to this. All right. So now it's equal to 0. Then the cosine have to be 0, right? So if f the param equal to 0, that means cosine of x equal to 0, and 1 minus sine of x equal to 0. Cosine equal to 0. So we have four points right here. Okay, so we have 1, 0, negative 1, 0, 0, 1, and 0, negative 1. So cosine equal to 0. We got this point and this point. So we got x equal pi over 2 and 3 pi over 2. And sine equal to 1. Sine equal to 1, so we got this point. So x equal pi over 2. So combine all of this, we only have 2 0. For the bottom is not 0 anyway, okay? So we just pay attention to the top. So we only take from the interval from 0 to 2 pi. And again, it's because it's a periodic function. So we have 2 pi over 2 here and 3 pi over 2 here. Now you just go ahead and plug in from 0 to pi over 2 for the f prime, f double prime. So f double prime is right here. So just plug in. For example, you can choose like 45 degree, which is pi over 4. Check pi over 4. Then you can check pi right here. And you can check like okay, 7 pi over 4, right? Okay, you can change for it to the degree, whatever you want to do. And then what you will get is minus right here, plus right here, and minus right there. So it's going to be concave downward, concave upward, and concave downward. Then we have the inflection point over there. So inflection point is f of pi over 2 and f of 3 pi over 2. We plug into the original function, so we will get 0 for the inflection point. Okay, After we're done, now we collect all of the information that we get above to make the graph. Okay, so we have 0 right here. So let's make like pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so first of all, we will put in the intercept. So intercept, we have y-intercept is 1/2 for on y. We also have the x-intercept. Okay, I forgot long time ago. So what is the x-intercept? Is pi over 2. Okay, so x-intercept is pi over 2, which is this point right here. Okay, and then we also want to plug in the inflection point. Inflection point is at pi over 2 and 3 pi over 2. So we got this point also. And this is the x-intercept also, because we remember x-intercept is pi over 2 plus k pi. So that is mean within a circle we have pi over 2 and 3 pi over 2. So the x-intercept is also the inflection point. Now let's looking for the local max and the local mean. What is the local max and local mean? In step number 6, so we have 11 pi over 6 and 7 pi over 6. So 7 pi over 6 and 11 pi over 6. And 7 pi over 6, we got negative 1 over square root of 3 and 1 over square root of 3 for 11 pi over 6. So this is the local max and the local mean. So 7 pi over 6. So we have pi over 2 right here, pi, and then we have 3 pi over 2. 7 pi over 6 is this, so it's past pi a little bit. And 1 divided by 1.7, so it's about 0 point something. So we will have the point is some here, like for example, like something like here. Okay, and then we have 11 pi over 6. 11 pi over 6 is very close to 2 pi, and we get the point is something like right here. It's more than point a half, so it's like this. Okay, so let's make the color. So I have this point, this point, this point, this point, and that point, right? Okay, so then let's connect them, and let's also check the concavity. From 0 to pi over 2, we have concave down like this. So we're gonna do like this. Okay, and then from pi over 2 to 3 pi over 2, which is from this interval. Okay, so we have concave up, so we're going to connect the points like this. Okay, and then the last one from 3 pi over 2 to 2 pi, which is from this interval, we have concave down, so we're gonna do like this. All right, and after that we're gonna check the for increasing and decreasing to make sure we get the graph correctly, and we see that we get the same answer as it said that f is increasing and decreasing. So when you're done with the first period, then you can copy for the next period. So let's finish up to 2 pi. You can plug in for 2 pi into the function, so that you can have a complete graph. Okay, because we look at from 0 to 2 pi, so we get something like this. All right, and then just look and copy. We make another 2 pi, period, which is 4 pi, right? And then you do the same thing for the left hand side. So you can copy this. Okay, and then do similarly for the left hand side. So you can do from here and then pass this like this. Like that, right? Okay, so we've completed the graph.